Section 4.7, um, applied optimization problems. Um, Problem number 6. So, a problem we have is Marcel is a lifeguard and spots a drowning child 30 meters along the shore and 50 meters from the shore to the child. Marcel runs along the shore for a while and then jumps into the water and swims from there directly to the child. Marcel can run at a rate of 4 meters per second and swim at a rate of 0.9 meters per second. How far along the shore should Marcel run before jumping into the water in order to save the child? So basically, it's asking how far should Marcel run before jumping the water so he can save the child in like the least amount of time possible in terms of optimization. So I have a picture drawn here. We have Marcel on the bottom left of this, and to the right is the shoreline up to 30 meters. And then from there, you go upwards where the water is. That's a child. And from going upwards, the distance for that is 50 meters. We are told that Marcel is running on the shore at a rate of 4 miles per second, and when he's swimming, he'll be going at a rate of 0.9 meters per second. He's obviously not going to run all 30 meters and then swim 50 meters. That's going to be slow because that's how optimization is. And he's obviously not going to just start by going to water, because he'll go at a slower pace if he doesn't cover any distance through the shore. So we have our equation of t equals d over r, which is just time equals distance over rate. And we are told that he's obviously going to meet somewhere in the middle by running a certain amount and then swimming a certain amount. So I have t equals tr plus ts. Tr is the time spent running, and ts is the time spent swimming. And basically over here, I marked the y on the small hypotenuse, and I marked the x from Marcel to at a certain distance where he's going to stop there and then start swimming. We don't know that value, so I put it as x. And then the remaining value would just be 30 minus x. So to get our small hypotenuse value, we'll use the Pythagorean theorem. We have 50 meters y and a 30 minus x for the smaller distance on the shore, based on my drawing that is. So we have t equals x over 4 plus y over 0.9. X is the distance he's going to go on the shore, and y is the distance that he's going to be swimming to the child. So after this, we want to reduce a variable so we can solve. And then we're going to solve for y by, again, using the Pythagorean theorem. So you can see y equals x to the second power minus 60x plus 3,400, parentheses around it, to the power of 1 over 2. And we're going to plug that in to the equation. And then with this equation, we're going to find the derivative of it. So t prime equals 1 over 4 plus 10 over 9 times 1 over 2 times x squared minus 60x plus 3,400 parentheses rounded to the power of negative 1 over 2 times 2x minus 60. So in this derivative problem, we end up using the quotient rule as well as the chain rule while adding them together. And the 10 over 9 here, I just basically converted the y over 0.9 just to avoid the decimals to make our equation look like they have whole numbers. And so that's our derivative. And then after we find the derivative, we set it equals 0, and here I set it equals 0, and I also chose to like simplify the derivative expression a little bit, which gives us 0 equals like 1 over 4 plus 10 times 2x minus 60, parentheses around that, all over 18 times x squared minus 60, x plus 3,400, parentheses around that, to the power of 1 over 2. And then here, we say this equals 0, just like the way we deal with our critical points. So over here, some algebra work. There's like a lot of steps. I reduced it to a few steps for the sake of convenience. And then once we get this equation where is 0 equals this decimal quadratic, we use the quadratic formula, and we get two values for x. X equals 41.5461 and 18.4539. Our answer is going to be the smaller value that Marcel needs to run on the shore before jumping in to swim in order to save the child with the least time possible. And the reason why it's the answer won't be 41.5461 is because the shore is only 30 meters. And if we go over that, there will be like no point because it would obviously increase the time it takes for Marcel to save the child. And that's it.